Okay, this is the P4 paper from October 2023. It's question number 8. It's the last question on the paper. You can see it's worth a lot of marks here, 1, 4, 3 and 6. And the topics is going to be to do with parametrics. We're going to be differentiating, we're going to be integrating, but it's a very long question, so let's jump straight into the video. So it gives me this equation, tells me that x is equal to this, y is equal to this. Be aware of what's happening with t for later on in the question. And then it says the curve meets the y-axis at 2 and the x-axis at k, and says, can we find the value of k? Well, yeah, absolutely, certainly. We can do that one. So part A, if I want to work out k, for k, we've simply got that y will be equal to 0. So y is 2 cos t. So 2 cos t is equal to 0. If cos t is equal to 0, then t is equal to pi over 2 within the limits of the question there. But we want the x value at that point. K is the x value. So x was equal to 6t minus 3 sine 2t. Oops, excuse me, 3 sine 2t. And I'm now going to put t equals pi over 2 into that. So 6 lots of pi over 2 minus 3 sine 2 pi over 2 is sine pi, which is equal to 0. So that just works out to be equal to 3 pi there. So k is equal to 3 pi. That's the first part done. I'm going to put it on the diagram, but I won't worry too much about it at this stage. So part A says take the value of k. We've managed to do that. Part B says use the parametric differentiation to show that dy by dx is going to be equal to lambda cosec t. Right, so I'll probably need to do some work later on to get it to look in that format, but getting started with dy by dx shouldn't really be too much of a problem. Part B, if I want dy by dx, let's find dx by dt and dy by dt. So x is equal to 6t minus 3 sine 2t. So dx by dt is going to be 6, and differentiating sine 2t is 2 cos 2t, but because of the 3 there, is going to be 6 cos 2t. Y was equal to 2 cos t, so dy by dt, then differential of cos is minus sine, so minus 2 sine t there. So if I want dy by dx, that's going to be dy by dt multiplied by dt by dx. So you'll have done loads of these, so obviously it's 1 over that one when we're doing it. So it's dy by dt, which was minus 2 sine t, all over then 6 minus 6 cos 2t, and then we need to get that into the required format. So when you're trying to think about what I'm trying to get it to look like, let's go back and see, it's lambda cosec t. The one thing at least to think about is I haven't got any 2t's in there. So that should make it clear as to what I want to do in terms of changing. I've got to change the cos 2t. When I change cos 2t, there are lots of possibilities I can change it into. 1 minus 2 sine squared, 2 cos squared minus 1 cos squared minus sine squared. Well, I would hope you would think if I change it to 1 minus 2 sine squared, then I've got sines in my answer all the way through. So this is minus 2 sine t all over 6 minus 6, lots of 1 minus 2 sine squared t there, which is going to give me minus 2 sine t over 6 minus 6, that's really handy, plus 12 sine squared t. Yeah, that's exactly what I wanted to have happen. So that works out to be equal to minus 2 sine t. I'm doing this really slowly here. You might take much less time than me over this, but obviously this is for the video, so just to make it really clear to any students doing it. that then tidies up to, well, that's minus a sixth, 1 over sine t. The sines cancel. In fact, maybe we'll leave that there, which is minus 1 over 6. Then that's where the cosec comes from. Cosec t there. So part B, yep, I got it in the format that I actually wanted to. Right, let's have a look now at part C. So part C says the point P with parameter t equals pi over 4 lies on C. So that's halfway. We've got a point P on there. The tangent to C at P cuts the y-axis at the point N. Can we find the exact y-coordinate of N? So let's just go back and look at the diagram and say, so what they're saying here is that we've got some line coming in here, and it's when t equals pi over 4, so it's sort of halfway point there. This line is going to go up and hit the y-axis there. Can we work out what n is? So this is a relatively standard sort of question we're going to do. What we're going to do is we're going to find the equation of that line, and if I can find the equation of the tangent, if I can find the equation of that line, then when I've got the equation, I'll just put in x equals 0, and it'll give me the y value there. So that's what we're going to do. Let's actually go ahead and have a go at trying to do that then. So if I want to work out the equation of the tangent, what I need is the point. So I need a point on the line, and I need the gradient of the line, because then I'm going to use y minus y1 is equal to m x minus x1. I'll do that a bit more when we're doing it. So for part C, so at t equals pi over 4, that was what they told me. Let's work out the x and y coordinates. So x is 6t minus 3 sine 2t. Sine 2t. So let's put pi over 4 in there. I'm going to get 6 lots of pi over 4 minus 3 lots of sine. 2 pi over 4 is pi over 2. So that will all tidy up to 3 pi over 2 and then minus 3. If we do y was just 2 cos t. So that's going to be 2 cos pi over 4. So that works out to be equal to root 2. So I've got my x1 and my y1. What about my m? Well, dy by dx was minus a sixth cosec t, wasn't it? We've already done that. So minus a sixth cosec t. So that's going to be minus a sixth cosec pi over 4. And that works out to be minus root 2 over 6. So all of those three things, now I can work out my equation of a tangent. Equation of any straight line is always y minus y1 equals m, x minus x1. I'm sure you've done this hundreds of times here. And if you've seen it on my videos, I always like to make it clear what all those points are. So in this case, my x1 is 3 pi over 2 minus 3. My y1 is root 2, and my m is minus root 2 over 6. So remember what we're doing here. We're going to work out this equation, and once we've worked out this equation, I'm going to be putting x equals 0 in to work out my, my value for n. So y minus y1 is going to be, what's that going to be? Y minus, let's just be careful, root 2 is equal to m, which is minus root 2, minus root 2 over 6, x minus x1, which is going to be x minus that is going to be minus 3 pi over 2, but then plus 3. That's a mistake that you're likely to make if you're not really concentrating here. You'll make it minus and a minus there again when we're not concentrating. So that's my equation. I don't need to rearrange it and try and make it look really, really neat. Remember, I'm just looking for n. So for n, I'm going to shortcut and say for n, we know that x will be equal to 0. So y minus root 2 is going to be minus root 2 over 6, and then it's going to be 0 minus 3 pi over 2 plus 3. And now I do need to try and tidy this up and get y equals with this. So I'm going to say y is equal to, just take the root 2 over the other side, root 2 minus root 2 over 6 minus 3 pi over 2 plus 3. Now again, I'm going to take a few steps here. You might do this much, much quicker than me when you're actually going through and doing all this, but I'm going to get y equals root 2, and then I'm going to have plus pi over 4 root 2, and I'm going to have minus root 2 over 2, and then tidying that up, y is going to be equal to, I've got pi over 4 root 2, and then the other two can just combine to make plus root 2 over 2. Now we can tidy that up and factorise and do whatever. Let's just go back and see, there's my answer, go back and see what they asked for n, the y coordinate of n, just in its simplest form. Yeah, I think that's reasonable. Yeah, I'm not going to do anything else to that, but you could factorise and you can take the root 2 out and whatever, but that's already in its simplest form. Right, part D then, the region bounded by the curve. The x-axis, the y-axis is rotated through 2 pi. So we're going to take this thing now, what we're going to do is we're going to rotate it about that, and what we're going to be trying to do is to find the volume of that solid, the volume of revolution, which I'm hoping you know is pi y squared dx, because that's what I'm going to be doing. So for part D, I think this is, if I want to find the volume of revolution, that's equal to pi y squared dx, integral of pi y squared dx. But obviously we've got it in terms of parametrics. That's going to be, I'll take the pi out now, pi, it's going to be y squared, but dx is dx by dt here, and my limits are going to be 0 to pi over 2. Let's just go back and look. Remember, we had t is going to be between 0 and pi over 2. That value there of 3 pi was on the x's, is going to be pi over 2 on the y's. So we've got that situation. So what that means then is that we've got to find dx by dt, and we've also got to find y squared. So dx by dt we already had. Dx by dt we'd done previously was 6 minus 6 cos 2t, and y squared is just going to be equal to 2 cos t squared, which is going to be equal to 4 cos squared t. So the volume is going to be the integral, let's take the pi out there, between pi over 2 and 0 of 4 cos squared t, and then 6 minus 6 cos 2t dt when we're looking at it. So here, if I want to tidy this all up, then what I'm going to do is I'm going to say, this time it's the cos squared that I don't really want. I want things to be in terms of cos 2t's. Cos 2t is much easier to integrate than cos squared t is. So we already had previously that cos 2t was equal to 2 cos squared t minus 1. So I'm going to rearrange that now. Some of the better students or the more confident students will be able to do this without doing this rearrangement. They've learnt it, that cos squared t is equal to a half cos 2t plus 1. That is a useful thing for you to be able to learn, because this is the way that we would integrate cos squared, is to change it to cos 2t, because you can integrate cos 2t where you can't integrate cos squared. But anyway, right, so that's going to take the place of cos squared t. So my integral is actually now going to become the integral between pi over 2 and 0 of, putting that in is going to give me 2 lots of cos 2t plus 1. Okay, because we've got the 4 and the half there, so 2 lots of that. Multiplied by 6 minus 6 cos 2t dt. Right, so I've done lots of this sort of work before. I know exactly what I've got to do here. So basically what we're going to do, let's just take the 6 out as well, and then I'll explain to you what we are doing here between pi over 2 and 0. If I take the 2 and the 6 out and put as 12 there, I've got cos, and let's write this maybe as 1 plus cos 2t, and then 1 minus cos 2t. So by I've taken the 6 out of there, I've put the 2 out there, so those two combine together. But the only point I've done that, or the only reason I've done that, is because I've got 1 plus cos 2t, 1 minus cos 2t, which is a difference of 2 squares. So that's actually going to now tidy up to, let's take 12 pi out there, pi over 2 and 0. If you multiply that out, you're just going to get 1 minus cos squared 2t. You try it if you need to, dt, and you'll get 1, you'll get plus cos 2t minus cos 2t, well, those two things cancel out. So once I've got that now, we're now going to be integrating cos squared, and I gave you a hint about how to integrate cos squared just a minute ago. I said, if you've got cos squared t, you can't integrate it, you need to change it to cos 2t. Well, we haven't got cos squared t, we've got cos squared 2t here, so I might be losing some of you at this point here. I've got cos squared 2t, so I'm still going to use the double angle formula to work it out. I'm basically going to go back up here then, and I'm going to say if that's true, then cos squared 2t is half cos 4t plus 1. It's exactly the same formula used, but just where we've got t here, we replace it with 2t. Okay, so I'm going to be using that then. So if I've got that and I'm trying to integrate that, I'm actually going to have 12 pi, the integral of 1 minus, this is going to be a half 1 plus cos 4t dt, again between pi over 2 and 0. You might need to go back and just have another check of that. I'm going to do the rest of this quite quickly, otherwise this video is going to get really, really long here. It's already pretty long. So this is 12 pi, the integral of, when we tidy all that up, that works out to be, in fact, actually, let's take the 12 out as well. Take the 12 out here, multiply everything all out here. This works out to be 6 minus 6 cos 4t, all between 0 and pi over 2 dt. Okay, so now we've just got to be able to integrate that. Well, let's take the 6 out. So, in fact, take the 6 outside. I don't know why I put that back in to then take it out there. We're going to have 1 minus cos 4t dt. That was a step too much, actually. I didn't need to do that. I could have just left it at that stage there. And so now we can integrate these. Integration of 1 is t, and the integration of cos 4t is a quarter sine 4t. It's a minus, so the minus will stay in there. Minus quarter sine 4t. All that's between pi over 2 and 0. Remember, we've got the 6 pi in there already. Just going back to see what we were actually trying to do there. Sorry, because I've probably gone the stage too far. Yeah, we were trying to get that bit there. I didn't really look at that, did I? So for the part 1, it says, can we show that? So yeah, we've done that here. Okay, and what we're now going to do is to actually go ahead and do this. So I've jumped into part 2 already here. This is now part 2, actually trying to solve it and find the answer. So if we're doing that, that's going to be 6 pi over 2 minus a quarter sine 4 pi, which will be sine 2 pi in this case, minus and the other one actually works out to be 0 minus 0 if you do those. So that all finally tidies up to 3 pi squared. And again, I'll let you go away and do that at your own leisure. But yeah, a really long question there, got quite complicated towards the end there with the last part of that integration. But it's question 8, it's the last question on the paper, so fair enough that that's a little bit difficult. Hopefully that all makes sense to you.